Welcome to C# Essentials. This course is a series of videos intended to help beginner developers and beginner developers in the C# programming language to get started and build their confidence. Welcome to the 6th episode of our series on C# Essentials. In this episode, we are mostly going to focus on hands-on demonstrations of concepts. The idea here is that we've learned already in previous episodes. If you haven't seen the previous episodes, there is a link in the comments below that'll take you to the playlist for the series. But in previous episodes, we showed you how to use simple single local variables with a data type. In this episode, we're just going to expand on that by looking at two ways that we can use what are known as collections of data types in order to make working with multiple values of certain types of variables easier. And that's what collections are for. And in this episode, we're specifically going to look at arrays, which are collections of a fixed size of a set of values of the same type, heterogeneous collections. And we're also going to look at lists, which are newer. Originally, when C# launched, it didn't have the concept of generic lists, which came much later, but they are much easier for working with when you're a beginner. So mostly in this course, we're going to focus on lists, but for the sake of completeness, we're going to cover arrays in addition to lists. Before we continue, please remember that the best way to learn how to program is to get your hands dirty, to try hands-on examples. And this is why most of the episodes in this series are largely recordings of hands-on demonstrations in VS Code with narrative and supported by occasional more theoretical slide content. If you have missed previous episodes and you'd like to catch up, there is a link in the comments to the playlist for this series, but it's also shown to you on the screen right now. So you can go there and go back to previous episodes of this series. Please like and subscribe. This really helps us to continue to produce this content and to help others and others who need to learn more about C# and programming in general. Please also share. Anybody you know that could benefit from this content, please let them know that it exists. And also, very importantly, please comment. Please let us know if you think we could do better, if you would like to suggest that we can improve certain aspects of our content. Please let us know. We really treasure your input. Thank you. Okay, for this episode, all of our hands-on demonstrations are going to focus around a very, very simple example. And that example is, imagine that we wanted to calculate the average temperature for a year. And one way that we could do this, if we were using simple local variables and we wanted to use doubles, because remember doubles allow us to use fractions, we could do something like this. We could say, I've got January, I'll give it let's say a value, and February, and so on, until we get up to December. Let's make that 17. So now what we could do is, if we added together all of these values and then we divide by the number of values, which is obviously 12, then we can figure out what the average is. So we could say something like double average. So we want to take all of these values and add them together and then divide by 12. But there's a couple of ways we could do this. A simple way of simple syntax is to do this, and then to say average equals to average divided by 12, which is fine. There's nothing wrong with that if you want to keep your code simple. But you could have equally put all of these additions in parentheses, like this, and then put the divide by 12 at the end. The reason you need the parentheses is because the divide operation takes precedence by default over the addition operation. So we want to do all of the addition first before we do the division. Therefore, we put all of the additions in the parentheses. So we're forcing the operator precedence, as it's known, to occur. We want additions to all occur and complete in the parentheses before we do the division. So I'll leave it like that. That's great. And then what we can do is we can do something like that, like this. We could say, let's interpolate in the string. We can say the average is equal to average, and do that. And now we should be able to run our app. Oh, we can see from the top here that I haven't saved, that the black dot says I haven't saved my code yet. So if I save it and then go .NET Run, it'll take a little while because the first time we run it, but there we go, we've got an average, and it looks as if it's roughly plausible as an average. So okay, so that's the simple way of doing this, but you can see that there are a couple of problems. It's really tedious. We've got 12 variables that we have to work with, one for each month, and then whenever we want to add them, we have to tediously refer to each one of them in turn. And this is a bit tedious and verbose, so we want to find a better way of doing this by working with a collection of double values as an alternative. Okay, fantastic. Now what I want to do is I want to try and find a better way of doing this. Now we know that if we add all these values together and we divide by 12, we get roughly 22. So we've got a kind of a model answer for any future attempt. If we take these exact same values and we add them together and divide by 12, we should get this average. So what I'm going to do is I'm going to put all of this code in comments. So far in this course, we've used only the // comment form, which is the C# comment form, which says ignore up to the end of the line. The syntax I'm using as an alternative now, /* and then terminated with */ is actually goes back to the C programming language. It's how we used to do this. And what I'm going to do is I'm going to take this code out of here and put it somewhere else, because we're going to use it later. I'm just trying to keep it out the way for the moment. Notice at the moment we have an error that says the average is not defined. So what I'll do is I'll just say double average equals to 0, and that takes that error away. Okay, so if I wanted to use an array of doubles instead of 12 individual doubles, for one for each month, I can use this kind of syntax. I can say double, and then I can use the square brackets, the opening and closing square brackets. This syntax, this open and closing square brackets, says that the variable that I am declaring, which is called months, remember if I'd done this, then it would be a single variable called months, a single double called months. I'm going to say is an array of doubles. I'm going to call it months, and I'm going to create it using the new syntax here, like this for a start. There are many ways we're going to do this in these examples, but this is the simplest original way of doing it. The new keyword you haven't seen before, it says we are creating a collection of something, a new collection of something. In this case, it's a collection of 12 doubles, one after the other. It's a sequence of 12 doubles. And now, if we want, what we can do is we can just assign values to those individual doubles, and we'll come back to that in a bit. And then after that, so we can do things like, I'll say here, assign values to the elements. We call elements each of the 12 items in the array we refer to as an element. And after that, we can say calculate the average. So we can do, if we want to calculate the average, we're going to, for the first time in this course, we're going to use the for each statement. For each double in months, double month in months. So what this does is it says I want to iterate through all 12 of these elements, one after the other, and when I'm working with it, I'm going to call each one of them month as a singular. And what I can do is I can say average equals to average plus month. And then finally, when I get, after I've done all of the months, I can say average equals to average divided by 12. And that, as long as I've got the same values as I had before, then I would get 22 as a result. So let's see how we assign the values to the elements. Let's look at the syntax that we can use in C# to work with each element individually. So we can say months 0, which would be January, is 25. Months 1 is the next month, we can make that 14. And so on until we get up to months 11. You can see that we started at 0, not at 1. At 1. 0 because arrays indexing, the indexing of arrays, this is the index in an array, 0, 1, let's do March equals, what did we have for March? March was 26, so we'll put that in. And these values 0, 1, and 2 that refer to the individual elements in the array months are known as the indices. So the index 0, index 1, index 2 of the array. Okay, so if we go all the way up to months 11, from 0 to 11 is obviously 12, then we could say that the value for December was 17. And now, if we run our code, let's see what we get. Okay, we get 22. And that's great. It's what we had before, so that's fine. I'm quite happy with that. But it's still a bit tedious, isn't it? The concept of having to assign all these values is a bit tedious. And another thing that could happen is, well, maybe we don't know what all the temperatures for the months are yet because we're only in June. We'll come to that separately. But one of the things we can do instead as an alternative to this syntax is we can simplify the creation. The declaration of our variable months can actually be done. I'm going to comment this out. And let's do it another way, and you'll start to see, hopefully you'll start to see the simplification of things. So here's my months equals to, and instead of saying new double 12, I'm going to put some curly braces here instead, and I'm going to take the values all the way up to the value for December. Let me see, 3, 6, 9, 12. Yeah, looks like I've got all of them. So I've commented out our old-fashioned way of doing this. Let's get rid of this. Don't need that anymore. And let's see if we get the same result. I'm going to save my code and let's run it again. And hopefully we get 22. So that's perfect. Much, much simpler syntax. And now I can get rid of all of this code that I don't need any of this anymore, and life is great. I'll leave it there because it's not bothering me. But look how much more elegant this is. We don't have 12 variables, one for each month anymore, and we can, because they are stored in one collection, we can use the syntax of for each, where we can iterate through all of the months that we have. And what's interesting about this is, let's say for example we were only in June, then we would only have 6 months worth of temperatures. So I can comment these out, and let's see what the average temperature was for the first 6 months of the year. Okay, that's interesting, and that's obviously because of the 14. So for the rest of the year, that's all very well and good. And this is fantastic. This is really great. And you need to be aware that there's one huge value of doing this, and that you possibly don't encounter some stupid mistakes that you can otherwise make. For example, if I comment this out again and I bring back our old code, sorry, not that code, this code here, and what I do is I do the assignment of the first 6 values. So months 5, which is June, is the 26th. And we save our code and run it. We should get 12, which is perfect, right? We've got 12, and that's great. However, if we didn't do the for each, so this code works right now. Now, here's where the risk lies. Is if I didn't use the for each statement and instead I individually added all of these months together, okay, so we add together all 12 elements, the values of all 12 elements, and then we divide by 12, and I save my code and run it, it still works. But the convenience of this syntax starts to show you how much value there is in terms of minimizing the amount of code you have to write to work with collections of values for variables of the same type. So we've got the homogeneous aspect, they're all doubles. We can deal with them as a collection, and life is really good. And so I'm going to clean up all the code that I don't need anymore. This is all unnecessary. We can now this is interesting, is that if we divide by 12 here, we're going to make a mistake. And this is one thing I should have pointed out before. This is a bug. Is that the average is not actually 12. It's probably, I think, about 18 looking at it, but it's not 12 because the 14 doesn't balance it out too much. The problem here is that only the first 6 months actually have a value. And if I, instead of adding the values together, I display them instead, let's do a interpolation here and just put the month value in, something like that. Oops, I need a quote. And I run it again, you'll start to see a problem. There are only 6 values. Sorry, I'm just trying to get this up. There we go. So there are only 6 values. So we're actually dividing excessively. There are only 6 values. The actual average is only for these 6 values here. And that's something that you have to be careful of, because the number of values is not 12. So what we would normally do, and this is really important, is instead of the 12, we would say months dot count. Oh, sorry, dot length. We would use the length keyword for the variable. So the variable is months, and length says the actual number of elements in this array is not 12. And what I'm going to do is take our console write line out of this, and I'm just going to say that we can display the length. Let's correct this. Length months dot length. Save my file, and let's run it again once more, and you'll see the result. And so what we should be able to see now is the length is actually only 6 elements. and the average is actually in fact 24.5, not half of that, because there's only 6 and we were dividing by 12. So a couple of really important lessons so far. We've got an array. There's a couple of ways we can declare an array, and there's a couple of ways that we can assign values to the elements of the array. The convenience method, which is this one, which we saw earlier, is great, and I can save this, and let's go have another look at this. There we go, we're back to our 22 for 12 elements. But this is the essence of arrays in C#. We're not going to look at it any more than that. The things you need to remember is you declare it with the square brackets, you initialize it if needed with the curly brackets. This is a very simple way of doing it. You can do a for each iteration through all elements in the array without having to index them individually as square bracket 1, square bracket 0, square bracket whatever. And you've got the length property, which you can use for your variable. Notice that this is the variable name dot length. It says how many elements are there in this array. I just want to point out that if I had an individual double value, let's say double mine equals 14 or something, I can't say console.writeLine and interpolate that in a similar manner. I cannot say mine.length because it's not an array. Mine is a single element variable. It's just a normal variable, so it doesn't have a length, but an array of any data type has a length that you can use to use it in calculations like average, and this is all great. So a couple of lessons there: the square brackets, the curly brackets for the assignments, and length. That is the essence of arrays in C#, and you can use arrays for all of the data types that we've encountered. So int, string, datetime, double, any valid data type in C# can either be declared. You can have a variable that is a single data type, an entity of that type, or a collection of an array collection of that type. So let's have a look at where lists come into this, because we understand our arrays now, and this is all very well and good, but the problem with arrays is that here's our example where we have our 6 months of temperatures, all very well and good, but what happens if we get further on in the year and we want to continue with the theme? Well, the problem with an array is its size is fixed after it's declared. So once this variable months has been declared, it can never have more or less than 6 elements. We can address the elements individually, as you saw earlier, with the indexes from 0 through 5, but we can't add another element. We can't make it 7 elements in length or whatever we want. And that's potentially a problem. In contrast, to get started with lists, let's have a look at a simple example. Instead of this, we're going to create a list of double, look at the syntax, the angle brackets, like that. It's not really important for you right now to know why we use this syntax, other than this list is actually what is known in C# as a generic. I'll type it in, but we're not going to explore generics right now. It's an advanced topic in C# that you really don't need to know. And because it is a generic, we're going to create it. Remember, earlier we did a double months. We did a double months, and we did equals to new double 12. So the new double 12 said create a new fixed size array of 12 elements and assign it and give it the name months. Well, now we're doing roughly the same thing, except we're creating an empty list. This empty list can contain doubles only. It's also heterogeneous, So it's very much like our array was in terms of it can only contain double values. However, we can have as many as we want, and we can add to it, and we can actually delete items, and we can search in it to find items of certain values and insert values and all sorts of things, which we're not going to cover in this episode. We're just going to cover the basics. So because we're only covering the basics, let's have a look at how we can use our months list. We can start, right now it's an empty list. So if I just save my code right now and run it, let's just run it. Excuse me. Once it's restored, we don't have a length. Sorry, we don't have a length. That's an important thing. With a list, length doesn't exist. It's actually count. And that's an important thing to remember. So instead of .length, which applies for arrays, .count applies to count the number of items in the list. Something you just need to remember. It's just a formal syntax. And what it's saying right now is that it's not defined. This NaN says we don't know. There's no values in the list, so we can't determine what the average actually is. We haven't got any values. But if we did something like this, where we say months.add, .add, and then we add 25, and then we say months.add 14, and then we finally add our sixth value, months, add the other 26, and we run our app, save our code and run our app, we get to our 24.5, which is exactly what we're expecting. So here we have this flexibility to add new elements to the array as we go along, and this gives us more flexibility. So sometimes you will have collections of data entities, be they strings or doubles or whatever, and you use arrays because you know how many you're going to have. And sometimes you will have collections where you don't, when you start the application, know how many elements in that collection they're going to be. Maybe, for example, you have a text file, and you're going to scan through the text file, or parse the text file as we refer to it, and every time you get a line, you're going to load that line as a string and add it to a list of strings in the text file. You wouldn't know up front how many lines there were going to be, so you would just create an empty list of strings, and then you would load each string from the text file into an item in the list. But this gives you the essence of the thing. Here we have a list instead of an array. We have the ability to add items to the array, but significantly we still have the for each. It still has a variable name, and instead of .length we have .count instead, but it's a much more flexible and often simpler mechanism for some people to understand. A lot of beginner developers seem to, for various reasons, struggle a bit with arrays, possibly because the indexes start at 0 and not 1, but lists are really simple to understand and very flexible and easy to work with. Thank you for spending your valuable time with us. Please join us for future sessions in learning how to code in C#. Please remember, as much as possible, to try to experiment with the hands-on examples we are showing you in these episodes. Please like and subscribe so that other folk can get the benefit from this content. And also, please let us know if you have any recommendations about changes we can make or topics we can cover in the future. Thank you.